Oh, go for it. Oh, here we go.
Go for it.
Well, thank you, everybody. ANYCon 2017 seems we've got some more people coming in. I want to thank Tyler and the guys from LeadSys for giving me the opportunity to come talk today. Noob 101 Practical Techniques for AV Bypass. I really hate this title, and when I was putting in my talk, I was more focused on the description, and I kind of left the title off because it's just kind of stupid on a few different levels. But really what it is my journey into really AV bypass, and we'll look at some cool techniques. And I don't want to disappoint. I was going to plan to do, all this hands-on demo kind of stuff, but I don't even want to roll the die too much with the demo god, so we got some videos and some of the techniques, but some pretty cool stuff. And I'm the guy before me was a little sick, so I don't necessarily want to roll with the microphone, so if you have an issue here, just let me know and I'll talk louder. But my name's Jared Hoffman. About a year and a half ago or so, I started this little local-based InfoSec security consulting company called Cyber Decode. All the content from the presentation today, the slides, we have a video. We watch a few videos, but all the videos are up there, as well as some source code for some different techniques I did. You can find some background about me and what the company does. Really, my background is offensive security, and that's really what we specialize there in. So what's the talk about today? So really the objective is, how can I deliver a well-known payload? And today's payload is an interpreter, the reverse HTTPS interpreter. Something that's well-known to a lot of AV vendors out there and still have it bypass kind of their detection techniques, right? So I'm not talking about, some new leak technique, 0-day, no ROP chain here. And I'm definitely not downplaying the role of AV, and it's actually the complete opposite. When I was doing this and I was running through some trial versions of the different AV to test, the one that I picked was super annoying in that base configuration out of the bat. It pretty much hated every technique I did and was always flagging things that I was trying to do. So I really got to appreciate that, hey, AV is very good at getting that low-hanging fruit. I wouldn't rely on it as a significant control to stop sophisticated based attacks. And these new kind of AV, next-gen AV kind of software integrate not just virus detection, but maybe some network controls, IPS, IDS kind of stuff like that. So there's definitely a role for AV in your security architecture, your security program for your endpoints. But it should be a defense in-depth approach, stuff that we probably tell clients, right? One control is not enough. You want to have multiple. And this worked for me today, and it might not work for you tomorrow. These AV companies have some very intelligent people that are trying to come up with new ways and new avenues for detecting, Trojan, virus, all that. I'll just use the term malware to detect that in the wild as we're trying to bypass those controls. So it's a back and forth kind of situation, but inherently, the benefit might fall to us on our side in terms of the offensive kind of perspective, right? So while I was doing some digging on this, I came across this guy, straight OG elite, Fred Cohen. And he wrote a paper in 1984 called Computer Viruses, Theories, and Experiments. And this guy is really for lack of a better term, like the inventor of AV detection techniques. And right in the beginning of his paper, in the introduction to abstract, he says, in general, detection of a virus is shown to be undecidable. And what Fred means here is that there's no single algorithm or process that he can apply to any piece of code, any piece of software that's going to give him a definitive yes or no answer, right? Is this AV, is this malware? Yes or no. It's always going to be gray. So that's really why it's kind of still the benefit might be on our side that, you know, independent of what kind of controls are put into place, there should be an avenue by which we can bypass those controls, right? So we knew this back in 1984, and we're still fighting that fight today. So what kind of techniques are we going to look at and try to get around? So signature-based kind of detection is, I see a program, I see a piece of software, and I already have a record of that in my AV database, right? So I've seen that before. I have a way to uniquely identify that software. It might have a hash or some variant of that. So I know of it already. It matches that signature. Hey, that's a virus. The second one is heuristics. And when we get caught in our examples here on heuristic detection, it's kind of static analysis. So it's kind of looking at, I guess, more the structure of that PE file. Hey, is this similar to something I flagged as a virus already? And if so, if it walks like a duck, talks like a duck, it's going to be a duck. So I'm going to flag that as malicious. Behavioral, and this is kind of like, I guess, quasi sandboxing, right? So what it's going to do is that executable in our in our context here in the demos, is going to run, and then it's going to see what is that executable doing. Is it dumping a lot of stuff to temp directories? Is it changing registry keys, or is it going to hit the network, right? So one big thing that we see is, when we start using the network, start using the wire, our AV is going to perk up. But based on the behavior, there's certain attributes that the AV vendor has. It says, when it's doing these kind of actions, I believe this to be a malicious nature. Now, usually the alerts that come out are, hey, this is suspicious, right? So it's not a definitive, hey, I believe this is absolutely a virus. It's just, this seems kind of odd. You might want to take some action. And then real time, and that's when, like your auto protection. So you download something from the internet. Whenever you're writing something to disk, or I believe writing to memory, download from the internet, pull down something from a file share, it's going to auto scan or scan that data right on the fly, and that's the real-time protection. So what are our scenarios that we're going to look at today? And this is kind of what Dave was talking about this morning, right? So how can we generate just that standalone XE, right? So just a portable XE that I can use across an enterprise, across multiple clients, that's going to bypass these detection techniques. So we'll see how we can go around generating that. So, we tried different frameworks. We tried Metasploit. We tried the Veil framework, and we'll get into that. And we'll see really at the end of the day, customization is really the best, or custom PEs. The second scenario is some stealth persistence. I don't know if anyone's familiar out there with a very sophisticated piece of software called Shelter by ANYCon, and it does some dynamic PE infection. So we're going to look to do some more sophisticated backdoor or persistence on machine once we've compromised it. And then this third technique, this PowerPoint mouse over action. Literally up until 2 days ago, this third one was just going to be a run-of-the-mill macro in a Word doc. But then John from Leetsys shared a dark reading article with me, and recently they've noted a lot of malware variants are delivering, their droppers via this mouse over action in PowerPoint files. So I was like, it's relevant, it's recent, let's check it out. So I incorporated that into it. And the third scenario also uses, it kind of plays a role in all three scenarios, but the third one, most importantly, is application whitelisting and bypassing that. So Dave spoke this morning about the new hit approach using the register server utility, the CLI regserve 32. So that third technique, we're going to show how you can use that to get remote code execution. And then once I have my remote code execution, how I can leverage PowerShell in a non-network fashion to execute that interpreter payload. So our victim today, just a standard Windows 7 Service Pack 1 VM. The AV software that I ended up going with was Norton Security. So this is not semantic endpoint protection. This is probably something that they'll sell to their home clients. I chose it because it was the hardest, if you would say that. It was without changing any settings, any configurations, just install and ran it. It really flagged on a lot of different things, and it was really annoyed when I tried to circumvent other things. So I said, might as well just use the hardest one. Now, one thing to keep in mind too, and it kind of goes back to what I was saying, this worked for me, it might not work for you. When we look at the steps that I hit, so like failure, and then eventually it works, certain AV products, you might only have to go down 2 or 3 steps and it might work for you, right? I chose this one because it really exhausted all those possibilities to really, what do I need to do to get around this piece of software? So it was pretty cool. It's got the auto protection, the real-time boot protection. The sonar protection is that behavior detection. We get caught up on that a few times, which is interesting. And then I liked it because it rolled in the smart firewall and then the IPS. We don't really get into exploit prevention here. So it's just more firewall controls, IDS alerts when we're trying to do our bypass. Our attacker VMs, the tried and true Kali Linux, really that's going to be our command and control. We'll use the framework for that to catch our callbacks. And then we also have a Windows 10 box that I'm running a community edition of Visual Studio on. And when we talk about building our own executable files, we'll look into doing that with Visual Studio. So one of the prereqs for the talk is, in the videos you'll see it, but I'm sharing these files between the attacking VM and the victim VM via just a simple VMware shared folder. So this is kind of taking into account that says, hey, you've already established a foothold on this machine. You already compromised it in some manner. When I'm putting these files or testing these files on the system, I'm not re-exploiting it every time. So just for ease of use, that was really what we were going on here. But just keep in mind, because like the first 2 scenarios, building that XE and using the shelter for the persistence is really kind of post-exploitation, right? The third one is maybe more phishing, social engineering, but they kind of go at the heart of, hey, you're already on the box with admin rights. What can you do from there? And if you think about it, if, let's say for the XE, and I was doing a pass the hash and I was jumping and I was pivoting, if I had an XE that I knew worked on one enterprise client, if all other clients within the enterprise kind of shared those same attributes, the same software, I would potentially have an XE that I could use over and over and over again, a custom XE. And then with the persistence, if you backdoor an application that again is across all the hosts, you can just leverage that intelligence, and what we'll see is it's an execution flow data, and you can backdoor that application time and time again, right? So we're not re-exploiting every time. Just want to get that out there. All right, so the first one is to generate the standalone XE, and really what we want to do at the end of the day is build a 32-bit XE for a Windows victim that's going to deliver our reverse HTTPS payload, interpreter payload, and really the ... at the end of it. Out of all this, what happens, the approach that I had that worked time and time and time again is building my own executable. So what we'll see here is I'll show you a bunch of failures, and a lot of those are coming out of frameworks, like default kind of settings, default configurations that AV software companies have known for a while and flag on very easily. Okay. All right, so this first one is really kind of our baseline, right? So this one, all I literally did was go into Metasploit framework and generate a XE payload for reverse HTTPS, and then put that onto my host, and immediately it picks it up very quickly. And it flagged it on the auto protect here. You can see auto protect. And then the threat name was this pack generic 347. And if you open that up and go to Symantec's website, that alert is associated with payloads or XEs that are packed coming out of the Metasploit framework, and that was from 2012. So they've had that signature in place for about 5 years now. So this is kind of like our control flow, right? So we already know anything that's just generic right off the bat coming out of the framework is not going to work. And then, so all these failures, also I have a video up on the website if you want to check that out. So the next step was, well, what can I do while I'm still in Metasploit and mess with that payload? And I came across this article by Logan Lemke from Black Hills Information Security, and he kind of breaks down the components of a interpreter payload, the stager, the template, and the shellcode. I really won't get into it, but what we can do is, those are 3 areas that we can modify to kind of get around that signature detection. And that's the first hit we got, was signature detection. The stager, when we're talking 32 versus 64-bit platforms, in our scenario, we're just going against 32-bit, so we can't really change that. But what I have found while testing other products is things that might get easily flagged on a 32-bit work on a 64-bit. So it's like there's a gap between those signatures. They haven't really closed that. So some of the simpler techniques that I'm using here, or the first kind of few failures, might work against a 64-bit system because that signature is not in place. That won't get you around heuristics or behavioral or firewall like detection, IPS stuff, but it will get you past that initial signature. So the shellcode already is going to be encoded when I generate it from the payload, but the really thing I focused on was the template, which is just kind of the wrapper that's going to execute our shellcode. So coming out of the framework, there's a default template that's going to be used every time. However, we do have the option to change that. So with a switch in the command, you pass it another Windows XE, and it'll use that as the template. So that's what I tried, and it failed, right? So this failure, I tried to use, I have my own lead speak here, but notepad.exe, a true legit Windows application, probably, signed and all that. And I tried to use that as a template. My payload came out and I dropped it, and heuristic caught this one. So it wasn't signature. They didn't have a signature for it, but it was basically saying, hey, I've already saw something very similar to this. You're probably also malicious in nature, so I'm going to flag you. Now, I don't have the slide here, but there's a video up online. If you take a third-party XE, so I tried SBD and Plink.exe, they will work. They will get you around this signature and heuristics, right? So I think I used Plink.exe as my template, and then I generated that out of the framework and then dumped that onto the client. It got around the signature and the heuristics, but as soon as I fired it off, the firewall caught me for suspicious or non-standard and non-approved network traffic. But just in this case, let's just say I try to do it to Notepad, and I didn't get around it. I got heuristics. Right, so there's a video for that. So then that brought me to Veil, right? Is anybody familiar with the Veil framework? My man right there. couple of guys. All right, cool. Veil framework. And everything I'm talking about here, I definitely recommend checking out. This is fantastic stuff, especially in our line of work where we're trying to do these during penetration, red teaming engagements. So the Veil Framework 3.0, the most recent one, is a Python framework which will allow you to generate a variety of executable files that at the heart of them will get around signature and kind of heuristic AV detection. They have a lot of intelligence pumped into it and different algorithms that will kind of generate these exes that are unique each time they do. There's not a lot of repetitiveness between them. So the two modules that we look at are Veil Evasion and Veil Ordnance. So Evasion is going to be that module that allows us to build the executable file, and then Ordnance is what we use to generate our shellcode. Right? So a couple of sources there, the GitHub, the veilframework.com, definitely check that out. So a couple of things happened here. The first one I generated was a Python-based exe out of Veil. Right? So straight Python with a reverse HTTPS payload. As soon as that hit the client, I scanned it and it passed signature and heuristics, all right? So the first hurdle was good. But then when I fired it off, I got flagged. And here our flag is the sonar, right? So this is behavior type of detection. And it says, this is behaving suspiciously. It won't come out right and say, hey, that's a virus, but it's like something's definitely weird here. And what happened was, when you're building a Python executable out of Veil, it has a couple of options of how you compile that Python code to an exe. And by default, it uses something called PyInstaller. So when you build that executable with PyInstaller and then you bring it over, and when I fired it up, what it does is it dumps a lot of content into local temp. And hopefully you guys can see that there. These are folders and files that the program's creating, prior to execution in local app. I think it's, app data local temp. And the AV was like, this is odd. And this is what really flagged on the sonar was, why are you writing and why are you, dumping stuff to local temp? So that wasn't an option. So then I generated a C# payload coming out of Veil. The C# payloads are compiled with Wine and I think CLP or something like that. I know they're compiled with some software within Wine. So it doesn't leverage that PyInstaller, so I could get around that dumping to temp. So I got around heuristics and I got around signature and I got around the behaviors, but when I went to execute it, that's when the firewall caught me. And what this is saying is, hey, suspicious network activity has been detected. Now, if I'm Johnny User, right, at the enterprise, and I'm trying to run my malicious exe without them really noticing anything, if this popped up, maybe they'll understand some of this stuff here. They'll probably get scared looking at a big exclamation point and some words here. They really won't have any idea what this is, network traffic. But you see here, the call was, I was calling back on port 443. So all my handlers receive on 443 in case there's like any host-based kind of firewall that limits traffic outbound. 443 outbound is usually allowed. But if you look down here, the default action is to block it, right? So right off the bat, it's going to stop it. And there's only like an OK button. So my feeling is, maybe you guys have a different opinion, but if I was the user, more than likely they're going to hit OK and this is going to get stopped, right? So this is where we get into the problem of, hey, I got around signature, you don't flag me, you don't think I'm suspicious, that's all good. Now I got to use the wire to make my callback and you don't trust me. So that's when we start looking at application whitelisting and the firewall is actually controlling what programs can hit the network and hit the wire. So that's what got me thinking, I can't use a framework, right? So now I started thinking, all right, I'm going to have to build my own, executable here. But even if I wrote an executable, I'm still going to be in the same boat that I was coming out of Veil, right? My executable won't be trusted. And as soon as I hit the network, it's going to flag me. So that's when I started thinking of injection, right? Injection in the sense where I'm going to take my shellcode, which is my reverse HTTPS. I'm going to inject that into a remote process. And then that remote process will execute my payload back in my handle. I'll pick a process or I'll pick a piece of software that's trusted, right? Something that can use the wire. So I'll start it off, inject my code into it, then it will run and I'll be able to get my payload out. So I was like, okay, so there's a book called Gray Hat Python by Jason Seitz, I believe, and he has it's a fantastic book and he has a whole chapter dedicated of how to do this in Python. So I was writing some Python based on that. And I thought to myself, well, even if I'm able to inject and it pops off, that's all good, but it won't get me around that sonar detection because by the end of the day, no matter what I write in Python, I'm probably going to have to build with PyInstaller. So I'll fall right into that trap of writing to app data local. So that's what got me into C#. That's a fantastic question. So, on Windows 10, I was looking around and I'm like, 64-bit systems, I need a 32-bit. And I came across OneDrive. Are you guys familiar with OneDrive? It's like the Windows cloud thing. That's what I used. Because it was already trusted, can use the wire. And we'll see in the video, when it pops up, it kind of seems like it's not really malicious. Like you see a little flash of a command prompt, but then you see OneDrive come up and you're like, oh, maybe that's some automatic or things. But we use OneDrive for the injection here, and then we use Google Chrome for the backdoor DLL stuff, right? So, great question. I don't have it here, and hopefully I show it. Maybe I show it in the videos. I go through the list of what's allowed and what we can inject into. The other thing about OneDrive, which was awesome, is the executable path is actually in my own kind of user profile directory. Things like C users. This was Spider-Man P Parker / something. So it isn't in program files. So I didn't. When I launch it, I really have full rights over it. So I can do the injection. I won't run into like administrative kind of privileges stuff. So I was like, how do I do this in C#? And if I could do it in C#, I have direct calls over those API calls. And I went around the internet, and this is where I found it. This dude named Zartrick on this World of Warcraft forum. I have no idea what it was doing there, but if you look at the last part, it's CASM injection. So he gets into how to write a C# program and inject your shellcode into a remote process. So we try that, and then boom, I get hit. So I generated it, and then I named it dumb name, dumb-name.exe, and I get hit with this Sonar Heuristics 158. And if you look at that, it's saying, hey, this is suspicious because it attempted to start a remote thread in a process address space. So literally, it was flagging on my injection. I was trying to start that process and inject into it, and the AV was like, no, bro, I don't think so. So I was like, this really got me mad. And this was like around April, and I'm like, man, I'm running out of time. Like, how am I going to do this? Get up there and show all these people, and it's not going to work. And then for some reason, I just changed the name. And I changed it just to straight malinject, and you'll see in the video, I just modify the name, I take the hyphen out, and that got around the Sonar. For some reason, it didn't put it through the behavior or whatever, and I did some testing on it, and let's say, you're running your malware, and you generate an exe with some, like, absurd number of characters, and they're all funky and done. It flagged on that, and it flagged on the hyphen. So I don't think it likes special characters. So when it was all lowercase alpha, and it seemed reasonable in length, I didn't have a problem. So definitely weird, right? And it's in the video too, so we'll take a look at that. So this is it, right? So I got around signature. I got around heuristics. I got around behavior, right? The Sonar kind of stuff. I got around the firewall alert by injecting into a trusted application, and then boom, I get hit again. And I'm like, pulling out my hair. I'm like, what's the problem here? And it's an IPS alert. And it's saying, hey, I detected a Meterpreter reverse HTTPS payload. Which got me thinking, I'm like, I thought this was over SSL. I thought this was a tunnel. How can the IPS see it? I knew I was in the right direction because when you scroll down and it's like, hey, where did this attack come from? You see that it comes from OneDrive, right? And I was like, I know I'm there, right? So we're injecting, but I'm hitting this. So I'm like, what's the deal here? So there's a video of that, and that's the first one that we'll take a look at in a second. But so I did some digging, and I came across this post by Carlos Perez. And it's a Meterpreter SSL certificate validation. And really what that IPS signature was alerting on was my handler certificate coming out of the framework, right? So it was kind of the default SSL cert that Metasploit's going to use. It saw that coming across the wire. There must be an attribute in that certificate that it looks for, maybe some random, string or something like that. And it flagged on that. So what I found was leveraging this module in Metasploit, impersonate SSL. What it does is it makes a self-signed copy of a legitimate, cert, basically takes the information from that. So this will give me that unique certificate that I needed to get around this IPS alert. So without even changing the binary itself, once I did the first build, I was all good. I just had to change some settings in the handler, and then boom. Once I did that, I got my shell here. So here we're running our handler, and finally I get the call back from Peter Parker over at Victim 7, right? So I finally get the call. So think about what I had to do to get to this point. You won't have to do this for every piece of, this isn't a silver bullet. This won't work for everyone, and this won't work for every AV product, but just this scenario, I had to do a bunch of stuff. I had to write my own. I had to leverage some C# that was out there. I had to do that injection into a trusted application. I needed an application that I had full control over, as well as the ability to inject into, and then I had to modify my SSL handler. So it wasn't really like, I wouldn't say, you know, it was difficult, but it wasn't like low-hanging fruit, right? So this is where I started to think like, hey, you know, we always rag on AV sucks and stuff like that, but it does have some usefulness in this context. Is I had to do some additional work to get there, right? So let's take a look at some of them. And again, I apologize. I was gonna do this live, but too much of a gamble. All right, let's look at the C# injection. This will show us some of the code that we use for this. And like I said, all the code and stuff is on cyberdecode.com, the blog. All right, and I apologize. That's about as good as we're going to get for the view. All right, so let's fire it off. So again, Visual Studio, Community Edition. This is Zartrix code, right? So this is his C#, and similar to what you'll see, like when you generate and execute a payload out of Veil Framework, they'll give you the Python or the C# as well. But really what we're doing here is we're including API calls to allocate memory and remote process, write our shell code to that remote process memory. Let's see if I can do double time here, yeah. Then we create that remote thread. That's the call that's going to fire off our shell code in that remote process. He defines some, these are our custom data types. And based on the values, I don't really understand exactly everything he's doing here, but I'm guessing that it has to handle the memory allocation and then the write permissions on that new kind of space of memory that we've allocated for our shell code. But this is where we come in. So now we have this byte array that's going to be our shell code. So this is going to be our payload. So where do we get that from? We go back over to our Kali box and we get it from Metasploit, right? So we're going to use the Meterpreter reverse HTTPS payload. Standard options, really. This is kind of stuff that you would do if you're using MS Venom from the command line, right? But you can also kind of do it within the framework as well. A couple of options. Those are my L host and L port. And one thing, so I use 443 here in case the firewall is blocking it, like any calling back out to or making a connection back out to 444, you know, the default. We're not going to go with that. 443 is probably, you know, allowed out because SSL kind of web stuff. So this is the key here, right? So this generate command is what I'm going to use to generate the payload. And my type down here is how what type of payload is going to be generated. Usually, or the ones that we were looking at before, I was generating exes, and you see that here, exe. But here, what we're going to do is generate the shell code in hex opcodes, so we can take it and dump it straight into the C#, my man. Who encrypted outbound to the listener? I don't know. That's a good question. I can find out. I don't know if it was encrypted going back out to the listener. I didn't sniff it. But after we established the tunnel with the cert, I'm guessing everything after that would be encrypted, but that initial callback, I don't know. All right, so we're going to do C#. And that X option was what we could use to change the template. But here I'm going to use some C#, and I get rid of some bad characters, right? No byte. New line and carriage return. Force encoding of the payload, 5 iterations, and then the platform is going to be x86, right? So this is what's going to generate that shell code for us. And it dumps it. Now, the reverse Meterpreter HTTPS is a dual stage, but for our exe, all we really care about is that first stage, which is usually smaller in size. So there is the hex opcode, so that's our shell code right here, a byte array of 494 bytes. So what we do is we take that back to our attacker and literally just dump it in, save that, because it seems like I'm, well, you know, I had to do the the formatting, and then we define what our the size of our byte array is, 494, and then down here we also come into play. So this is where I'm launching OneDrive. Right? So I'm getting the environment variable local app data, which will point me towards the location of the OneDrive. I start that process, and then this variable proc gets the handle for that OneDrive exe. So that handle is what I start passing to my allocation calls for when I'm handling the memory. So the handle is going to point back to my OneDrive. So every time this runs, it will start OneDrive and then inject into OneDrive. Oh, and then this is something I was messing with too. It doesn't really come into play, but I figured I'd tell you guys. Sometimes sonar, if the XE fires off and then immediately goes for the network and starts trying to send data, that will flag. So what I did there is a little sleeper delay, right? So don't call the remote thread, don't start that shellcode until you sleep for, I think this was a minute. All right, so, and all I'm doing here is just building it. So I'm just deleting, something I had before in there, and then I build the solution. Doop, 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 succeeded. And then I take that mal inject.exe and I bring it over to that shared folder. And then I change it to dumb name. So we go back to our victim. I start my AV as administrator. For some reason I take a look at the history just to see that there's nothing in there. I go back to the shared folder and now I pull dumb name onto my desktop. Now here is where the auto protection is. So even just that simple copy action, I'm getting scanned. The longer it stays on the desktop, the better shots I have that I've gotten around signature and heuristics. But just to hammer home, I do a quick scan on it. And we get the green light. No threats found. Perfect, right? So now we fire off the payload. And we don't really get too far. So OneDrive popped off, but then we get hit with the sonar, right? So there's our sonar heuristic 158 coming into play. I don't know exactly what I'm doing there, but I should follow the link. If I look to the more details, and then they even had a drop down. You look here, it's suspicious actions. Why did it think it was fishy? And then here's the attempt to start the remote thread in a process address. So it didn't like that, hey, I was trying to do something in another process besides my own. So I close that, kill that, and then clear the list of the history. But we go back to there we go. I go back to the sample payload, and instead of dumb name, I make it same PE, right? So it's the same file, just a different name. Now it's just smaller alpha. I do a scan just to prove we're still, bypassing. And then when I hit the open here, I no longer have that sonar. Now I have my IPS set. So now I got past that whole, hey, this seems odd, you're injecting into a remote process, but it still caught me for that SSL. So OneDrive always pops off because I start OneDrive before I start to trigger my remote thread, but the interpreter doesn't go through. Go for it.
You got around the SSL by using the impersonate SSL.
Exactly. So you'll see that in the next video, right? So there we are, our intrusion attempt. We're still getting caught, which we don't like. Kill that vid, then this one. There's the right one. Got a bunch of them open. All right, this is where we do the impersonation. So this one I'm just going to play a little faster because we don't have to go through everything again. I'm just showing here that, hey, this is the same PE file. This isn't something, I didn't change anything. It's the same thing that we saw in the previous example. I do another build, bring it back over to the share folder, delete the old one. Copy it over. Scan. Again, no problems. We got around that. Fantastic. Our history. For some reason, I don't know why my videos, I figured I wanted to prove to the user that there wasn't in the history or anything, but that didn't work because I forgot to start my handler. I'm like, where's my, the AV's not flagging. What happened? I forgot to start the handler on the other end, so that's why that didn't go. But as soon as that goes, boom, I get hit. So at this point, we're still in the same boat, right? We're still getting caught by the IPS. And we're still injecting into that OneDrive, which is, ideal what we want to do. So how do we get around the SSL issue? We go back over to Kali. And really, it becomes a setting changer, like I mentioned before, in the handler. This isn't a change to the binary. This is only a change to the handler. And the two things that we're going to use more importantly is this one, handler SSL cert. So this is the SSL cert that the handler is going to use. So By default, it's not set, it's blank, it's just going to use the default one in the framework. We're going to use that one with an impersonated one. So this is that impersonate SSL option. And I think I do an info on it, right? So this module requests a copy of a true remote SSL certificate and then creates a local self-signed version using the information from that. So that's what we're going to do with that. And then when you run it, which one did I use? Set our host, Google. So I said use Google, and then run. And then this is what we want. It creates this PEM file, and then that's what we pass for our SSL certificate. So we copy that. Looks like I had a problem typing there. Go back to my handler. Now these are in the advanced options, right? That handler SSL cert. And then here, I've set that value to that PEM file from coming out of the spoof there. And then I set the verify SSL cert to true to verify that. So I don't have my active job, so I start my job again. And this time I go back over, refresh, same binary that was flagging before, right? OneDrive is not running. We start it again, little shell, OneDrive opens up and nothing. Looks like OneDrive's running. Bam, we got the shell in the back end. So here is our connection. That is our interpreter handler coming back from the victim. The victim is 155. And one thing I do here is we interact with the session. Victim 7, P. Parker, Superman's in the Spider-Man's in the house. This is the process ID of our interpreter, right? So our interpreter shell, 3208. If we look at all the processes running on the system and we find 3208, right there, OneDrive. So that's how we know that our interpreter is in OneDrive, right? So that was pretty much ideal for us in terms of getting around this. And then just for confirmation purposes, it's the victim 7. And I think I do a get UID at the end here too. Just to say, hey, I'm P. Parker. Oh no, I background it. All right. So besides that first initial encryption question, is there anything else on that technique? This is all up, like I said, on cyberdecode.com if you have any interest. Go for it.
What would it take to inject into already running process, say like Chrome?
The only thing I could think about that would stop that from happening is if you didn't have rights to do it. So if Chrome was running under a different account or an administrative account and you didn't have the privileges, that could stop you. But let's say OneDrive was already running, and it was running under my context, P. Parker, I don't think that should be an issue. This one, I also had a line in that C#2 that would kill any OneDrive instance and then start it again. I just found it probably would be best if I just started fresh and started a new OneDrive. But I don't think there should be any issue with that. All right. So the next scenario, how are we doing on time? 3:38. Okay. Shelter Pro. Has anybody ever used Shelter before? It's basically it's an unbelievable tool. It does PE infection or injection in a different way. So usually when we think of PE infectors, we think of maybe trying to find a code cave and stuffing some code in there, or maybe appending another section to the PE file. But what Shelter Pro does is it executes that software and then traces the execution, and then it has more kind of intelligent, sophisticated ways of how can I inject my shellcode in there. So it's more dynamic as opposed to kind of like I said, just kind of appending new stuff to a PE file. So this comes out of Shelter Project, or at Shelter Project, it's a Twitter handler. I highly recommend going out and supporting this product. It's a fantastic tool, and it's really, it's redefining AV evasion is what it says on the website, but it's very good. The version that we're going to use is the Pro version, so definitely go out there and support them. Pro version 2.0 that came out in, I think, like a month ago, allowed us to do this injection into DLL files. So right now it's only limited to 32-bit executables, but now we can do our injection into XEs or DLL files. Right. So what we're going to do is inject a DLL file. So which one are we going to choose? Chrome. For the same reason that we picked OneDrive. we can initiate the process. It's a trusted application in terms of the whitelisting, and it's allowed to use the network. Plus, if we're going to use this in the context of a backdoor, this would be pretty ideal for us because everybody loves the internet, especially during the workday. So if I can get my payload to run or execute every time somebody opens the Chrome browser, that'd be pretty ideal. So that's what we're going to do here. And the video's out there on CyberDecode as well. Sheltered. Full screen. So Shelter is portable too. You can you don't need to install it to the host. So you can, if you compromise the machine, you can bring it down and do your infection on the host as well. And then another pro feature that we don't get into today, but it's called execution flow data. So once I trace an application or I trace that DLL, I can use that EFD many more times without having to do that trace operation over and over and over again. What it's going to do is take the configuration from that EFD and just apply it to that DLL that it has been seen before. But this is a full run of how I injected that file. So I did it here. So here is in the firewall settings, these are the programs that are allowed to hit the internet. And you see here we got Google Chrome is allowed. I wonder if I scroll down and I don't show OneDrive, but OneDrive was also in that list. So in order to determine the DLLs that Chrome used, what I did was I just started Procmon and did a bunch of filters. The path contains Google. What else did I put? The process name should be, what is it, chrome.exe? Yep. And then the last one was just trial and error that I figured out while I was working with. So result is success. And what that means is when it tries to access a file while it's executing, whether it was successful in doing so or it was not successful, I want to know that it was successful because then I know these are absolutely the files that it's working with. So when I launch that and then I launch Chrome, boom, Procmon fires off a bunch of different stuff. And I think I just go to like time.gov was my example here, right? So this should illustrate too, the browser's working just fine. Everything seems to be, on the up and up. But I go through and I find a DLL, and it's hard to see here, but it's called Chrome ELF DLL. And it's called a lot of times by Chrome, right? When it's executed. So I'm like, this seems like the perfect thing. So I copy the path and I go take a look at it in the file, in the folder structure. And then there it is. Right, so I take a copy and I drop it to the desktop, and then I fire off Shelter Pro, right? This one I was a little more smart about the font. What we're going to do is in operation mode, we're going to do manual. If there's a community version of this out there, so if you want to play around with it, I highly recommend it. And what's our target going to be? So our target's going to be this DLL file. So we copy the path there. Speed this up, right? So these are based on that DLL, what does it support? And we see that it supports also stealth and multi-mode. So stealth mode allows it to maintain the functionality of that exe or that DLL. So even though I inject it into it, it's not going to break it. And then multi-payload allows payload chaining, where I could have, a bunch of different shell types or a bunch of different types of shell code try to execute. But we don't do that. We just stick, yes, we want stealth mode in this, but we don't want any payload chaining. This is where I would define, if I want an execution data flow. And then this is the key part. These are the exported functions from that DLL. So the trick is I need to find a function that's used and then put my inject into that. Now, I got to be honest, this part was definitely trial and error. I messed around with a couple different functions until I found one that worked. And it was that get handle verifier, right? So I define that as my injection point. A couple different options here in terms of self-modifying code while tracing, and do I want real-time tracing, but no. So at this point, now the tracing has begun, and it's hard to see up here, but it's running through the instructions. And basically what it's doing is running that DLL, and it's going to determine when my function is called. And we're just going to go faster here because this takes a while. So I don't know what I was doing with Notepad here, but I also show, I think I fire off. Oh, we hit around 100,000, it stops. So that's when our calls hit. But we're still doing the trace, we're still loading it. So I think what I do here is I think I show, yeah, Task Manager. And this is a VM that it's running on, so obviously Shelter Pro here is, you know, kicking his ass. Boom, boom, boom. All right, and then now it's stopped. All right, so the tracing is done. It knows how to infect this PE, so what payload do we want? We select the payload that we've been using all day, the HTTPS reverse shell, and this is built into Shelter Pro, so I didn't need to bring in a shell code, but that is also an option. Now, this is also key too here. When we were looking at the C#, we saw that virtual allocate kind of approach to getting the shell code in. In this context, in order to maintain stealth mode for Shelter, we utilize this heap create, heap allocate, which I really don't know too much about, but it seems like that's the only one that's going to be allowing us to support that stealth mode, which is key, right? We don't want them to open the browser and then have it crash. Irregardless if we get a shell back, that's going to raise attention. They're going to be suspicious of that, right? We want to be stealth, complete backdoor here. So we're going to use the heap create. We select 4. And then it asks me some options about prepending polymorphic code and different types of encoding. But this is the key, right? So our injection has been verified. The payload, the shell code, has been injected to the DLL, and it tested it to make sure that it gets executed. So at this point, that DLL file is injected with our payload. Right? So there's the file. And just for purposes, I scan it, right? So even after the injection, it bypasses the AV. So all I do really now at this point is dump it back into Google. So the original one I renamed to .bk, and then I drop this in there. So now that my quote-unquote malicious file is there. And then my handler for Shelter is going to be the same handler that we used before, and I'm still defining that SSL cert, right? This is still the same host. I'm going to run into that problem, so I need to make sure that my handler is prepared to do so. So again, I'm going to use that PEM file from the auxiliary module that we used. I start my handler. Boom, 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 fires off. There we go. It's running. I'm port 443. And then this is all they do is fire off Chrome, right? So now the victim opens Chrome, and just to show that it's working, I go to time.gov again, right? And this time, there we go, 12:18 a.m. When I was doing this. So the browser's working like it normally would, but on the back end, shells, right? And the thing about it is, when you looked at the procmon output, you saw how many times it called Chrome ELF DLL. So every time that's getting called and there's a possibility my function's running, it's going to make that call back. So that's why you see multiple sessions kind of coming back here. And then we list them. The best one's probably always going to be the first one. So when we go to that, we get our process ID. And our process ID here is 5064. So that's the process ID for our interpreter. And then when we look at all the running processes on the system, we see 5064 is Chrome EXE. Right, so I'm in the Chrome context. Again, I'm leveraging a trusted application to get around that bypass to deliver my payload. Another one pops off because I think I left Chrome open. And victim 7. And that's it. Like I said, I go out there, support this product. It's fantastic. And this is literally just the tip of the iceberg, what you can do with Shelter. All right. So the last one. This is the coolest one. Dave talked a little bit about this in the keynote this morning. So originally I was going to, deliver this through a macro using some PowerShell. I was actually going to use ANYCon that he showed this morning to make a malicious reverse HTTPS macro, put that in a Word doc, and then deliver that off. But I got caught, and I'll show you what I got caught with. But then, so I figured out a way how to get around that, and I was still using the macro. And then John from LeadSys sent me this article on, this mouse over action, and I thought that's pretty dope. So there's still a click needed. Don't get it twisted. You still need to click something, but to initiate the process, you literally just kind of hover over it. And I'll show you this funky. The video gets into this PowerPoint that I make, and it's kind of evil in terms of what I do to the people. But what this is also going to do is, Dave mentioned this morning, it leverages that register server command line utility, regserve32, and it passes it. When Dave said this morning that it's proxy aware, what it does is I can pass it a remote file, right? So I pass it the location of a remote scriptlet, a COM scriptlet that I'm hosting. And what regserve32 is going to do is go out and get it in memory and then execute that file. And then I inject my VB script into that SET file. That's what's going to give me the remote code execution. What that remote code execution is going to do then is going to, it goes from file list to I create a file. And basically what I do is I create a C# file on the host. I compile it with csc.exe in a manner which install util can run it, right? So I'm still going to hit, even if my hook works and I write my file and I compile it, I'm still going to hit that, hey, this isn't a trusted exe, I don't want to run it. But when I run it in the context of install util.exe, I get around that bypass. So these are two different kind of techniques that I kind of put together to get around this, to get this fish going. So why did I just give up on PowerShell? So when I put that unicorn macro into my Word doc, and I opened the Word doc and enabled macros, this is what I got hit with. And it was a Sonar hit, sonar.ms office IG7 or something. And when I looked into the web page, it said, hey, this is a heuristic detection for a suspicious process launched by Office. So it didn't like that Office was launching PowerShell, and it really didn't like that once PowerShell launched, it went to the network. And if you see when they released this, it was April, like the first week of April this year. So it's like perfect right in the middle of when I'm getting ready for this presentation. They hit me with it, so I'm like, okay. But you know what? I think that's the benefit of this is like when I hit those walls, I had to think of new ways to get around it and stuff like that. And it really opened my eyes to different techniques that are out there. So Dave mentioned this morning too, changing PowerShell.exe to like moo.exe. That might have worked in this case. I didn't think of that. So I figured out like, how can I get around this? So I went digging on the internet, and that's when I came across this post from Casey Smith of Subt. From April of this year, and really how to bypass application whitelisting using regserve32. So this is the command, right? This is going to be my hook. This is what I'll put into my PowerShell file. When they hover over it, it's going to run this command. And what this command is going to do is cause the unregister action for this malicious SCT file, which is sitting on my Kali box. And then the script object DLL is going to run it. So what that SCT file is going to contain is my payload. So here's what the SCT file would look like. This is actually in the registration tags. That's what's going to execute your code. And it actually looks very similar to a macro here, right? We create a script shell object, and then I run my PowerShell. And there's a bunch of stuff behind this. We'll see in the video of what that payload looks like. And if you were if they were trying to alert to PowerShell commands that are over like 255 characters, this technique would definitely fall into that. So the lifespan of this potential attack technique is probably very short. But that's what that SCT file will look like. So that victim host is going to go load that in memory and then execute my PowerShell here. But I already told you that in the context of that I was hitting that AV catch, that sonar catch. So my PowerShell here can't be my connection back. How can I leverage PowerShell to get around that connection? So that's when I get into this technique, right? So another guy coming out of Black Hills InfoSec, Brian Furman, wrote this, I think this was last year, of how to bypass application whitelisting in AV. And what they say is leveraging these executables, csc.exe, which allows us to compile C# code on the command line, and then install util.exe to execute our executable. So really what my PowerShell is going to do is determine the location paths of these files, generate that C# file, compile it, and the C# is written in such a manner that when it's run in the context of install util.exe, it understands it. And really what that means is there's an uninstall function in my C#, and that runs my shell code. So more from those together. And then finally, this was the article that they sent in terms of this mouse over technique, relying on users just hovering over the hyperlinked text and images, and then to drop the Trojan, or in our case, our interpreter payload. Users still need to enable the content, right? So if you've ever, done some testing in your own lab or something, and you get that, hey, enable macros button at the top of a Word doc, you got to hit that in order for things to pop off. In this context, you'll see it's kind of actually a little scarier message, but there's always going to, well, there's not always, but in this context, there's going to be a click needed. But once they do click, right, we get our shell back. And when we look at the context similar to how we were looking before, now I'm running under the context of install util.exe. So at the end of the day, all three scenarios, standalone XE, the shelter, I was never running under my custom, like Jared.exe. It was always under something trusted or something, you know, something that the system doesn't mark as suspicious or won't think, hey, this is some odd behavior. So this video I just made yesterday. And actually it's a little better because I upgraded like the size font and stuff on it. So hopefully it's a little easier for you guys. All right, let's get into it. Now, I got to keep in mind, I didn't think I'd have to do the video stuff, right? I was hoping for the demo, so I got these weird little outputs, right? But we're going to get that remote code execution via the COM scriptlet, right? So we host that COM scriptlet file on our web server on our Kali box. So if we take a look at what that looks like, boom. So here is the scriptlet file, and like I mentioned, within the registration tag is where we're going to run our PowerShell. So here is our little VB script. We create our script shell, and then here's our PowerShell. Ignore this one. This is actually, in case anybody's wondering, this is a command line how to delete somebody's internet history from IE, if that's of any interest. But what I found was if I ran this multiple times, I was like, how come it stopped calling back for component.sct and it caches it, right? So if you're testing and you make some changes to your SCT file and you run it again, you're like, that doesn't seem right. Make sure it's not caching it and delete that internet history. But here is really what it's going to execute or run this command, and here's our command, this PowerShell base64 blob of data. And it's gigantic, right? So if they were flagging on PowerShell commands that are large, this would definitely fall into that. So what exactly is that PowerShell payload doing? Let me take a look at that file. So really, the first step, I need to determine what are the path locations for csc.exe and install util.exe. If they don't exist on the target that I'm going after, this technique will not work. Right, so what I do is I use a little PowerShell to enumerate the registry, and I recursively go through the registry under the .NET framework kind of location, and then I kind of generate an array of different path locations, and then I append in all that good stuff. Right, so now I know every place that install util is there's a valid path to. And what I do is I then test the path. I see, hey, does this file exist already, this program.cs and program.exe, which I'm going to create, and if so, delete it. So it's a fresh start each time. But the key is here is this environment variable. We already know that writing to app data local is going to get flagged as suspicious. So here I'm literally just writing it to the user's pictures directory, and they didn't have any problem with that. So, all right, so I create the file, and then all these PowerShell commands, right, this write output is just creating this C# file, program.cs, right? So it's write this to the out file, write this to the out file, write this to the out file. And the key is here is I'm writing it in a context that install util.exe can work with, and we see we are using the system configuration installer here, and then this is the key. We have that uninstall function. What uninstall does is it calls shellcode.exec, and then shellcode.exec is where our payload is. And I think all I do for the remainder is just kind of highlight that stuff, like, oh, here, this is key. The payload is the same payload that we used, and instead of having to do this in a remote process, like inject, since I'm going to be running under the install util, I can just kind of do a standard virtual allocation for doing this. So we allocate the memory, we create our thread, and then execute and wait for the callback to see that it's done. And then right here, so the last part is I iterate through my array of path locations, and here is this command. I'm building the exe from the program CS that I wrote with using cs.exe, and then I invoke expression command there. Fantastic. And then once that's built, let me get this out of the way. Once that's built, I use the install uxe path, and this U is why we put the uninstall function in there. It's basically saying uninstall this exe. Right? So when it goes in, it calls that uninstall function. I'm going to run my shellcode. All right. So those are the big files that really the one that shows the PowerShell doesn't come into play here. I just took that base64 encoded it and then put it in the SET. Again, we're going to use that SSL cert that we used to get around the IPS attack. But I'm also going to show the call to the component file. So I just tail the Apache access lock, right? So right now on my C2 server, I'm just watching the access lock to see the call for component SCT, and then this is my handler to when I get my call back from the interpreter payload. All right, so now we're on my malicious Windows 10 machine, right? So we start our PowerPoint. Let me, we don't have to do this in fast speed, this one here. So I basically make a presentation, I kill the first slide, and then I just write some generic kind of FIS message, which I thought would be appropriate. I don't know. So click enable from the dialog prompt below. Right, something that would be, instructing the user to do something. So instead of having a hyperlink or text, what I did was I took a screenshot of what that message looks like. So when they get hit with the message, that's what the prompt is. So I make the prompt all big, and I put a nice green box around the word enable to really drive home, hey, this button is legit, you can click it. But this is where the cool part comes in. So two things. First, I save this as a PPS file. Does anybody know what's different in a PPS file? Basically, a PPS file just opens straight to presentation, right? So it won't open into edit mode. It will just open like you're like I'm standing up here and I'm showing my slides. I don't know, I think I name it ANYCon. So right now I have the base, right? So now I need to put the hover over action in. And what I use to do that are these things called action buttons down here at the bottom, right? So instead of inserting like a shape, I insert an action button. So if we take a look at that, I use a custom one, and I just drag it right over that whole image, right? This big blue blob over it. And then this is key. My action settings. What can I do with that action button? Two options. What happens when it's clicked, and what happens when it's, moused over. You see here, run macro and object action are disabled. Usually there's additional security controls or maybe a group policy that's going to prevent that. But what they don't prevent is run program, right? So in run program is where I'm going to put that reg serve32 hook. So all I'm doing here is just browsing to the path. Speed it up a little bit, right? So I take the reg serve. I'm going to run reg serve. But what's my hook? Luckily, I put a little text file on the desktop to tell me, so I didn't have to memorize it. But that's the hook, right? Reg serve32, unregister this remote component SCT file, and execute it, right? So that's all I needed on that action. So I just copy paste those switches over. Again, component.SCT, space that. And now I got my hook, right? But who's going to mouse over this? This looks ugly as it is. So one thing you can do is you can format the shape. So I go, all right, no fill and no line. It's like it's not even there, right? So they don't even see this action shape. And what I do then is I duplicate the slide 3 times. Now, why did I do that? When you're in a PPS view, to progress to the next slide, you click it. So I figured if the user's freaking out and they're just kind of clicking and clicking, they're just going to keep getting hit and hit and hit and hit until they get out of the PowerPoint. But right now, it's set to go. Yeah. This is the last thing. We'll leave it going. So I put it on the share. I drop it over to the victim. I think I scan it again. Right, so now it's on my victim machine. I scan it with Norton. Everything comes back clean, fantastic. Now, at this point, my handler hasn't gotten anything, but when I show it, right, it opens up. And then boom. As soon as they move the mouse a little bit, they get the prompt. And there's the prompt with the enable button. The user's like, oh no, what do I do? I'll enable it because that green. And then boom, they enable it and then it runs, right? And they're still there. They're still not out of it. So they're keep clicking and clicking, and then finally they get caught. Now, every time they click, though, they went to that next slide, and that next slide gave me another shell. So here you see they made that call back out for component.sct, which is fantastic. And then I got a bunch of shells. And then just the one last thing I want to show is if we interact with the first session, get that process ID of 5536, and then we look, and 5536 is install util.exe. So there we go. That's it. Thank you, everyone.